So let's take a look at the method of annihilators, and this time we're going to look at it for repeated annihilators or modified trial solutions. So sometimes our complementary part and our non-homogeneous part are going to actually contain similar differential operators or similar linear operators, and we're going to have to account for that inside of our trial solution so that we don't end up with linearly dependent solutions, right? We want to create linearly independent solutions, and so consequently, we're going to actually have to modify our trial solutions in order to deal with that, okay? So let's take a look at this example right here, all right? And I'm actually going to run the annihilators here to kind of show you what's happening and why it's so important for us to modify our trial solution. So what we get here when we factor is we're going to end up with d, right, um, minus 1 times d plus 3, okay? Y equals 3e to the negative 3x. And so we've been doing the modification, or excuse me, we've been doing homogeneous differential equations with constant coefficients long enough to know that this is going to give me, right, a complementary solution of e to the e to the x, right, or pardon me, y complementary c1 e to the x plus c2 e to the negative 3x. Okay? But then we notice that what we have here is we have negative 3x. E to the negative 3x is both a part of our non-homogeneous part and also a part of our complementary solution. And so consequently, my trial solution can't be just e to the negative 3x, right? I mean, take for example, if we had like 5e to the negative 3x, right? Whatever C2 is, it doesn't even really matter what C2 is, right? Whatever C2 is we're going to have C2e to the negative 3x, right, is going to be some scalar multiple of 5e to the negative 3x, all right? Okay, so you're going to have that kind of scalar multiple, and so consequently, not independent. So that's a problem, right? We need them to be different in some way. We need a, power of x is actually what we did when we had the constant coefficients, when we did the homogeneous parts. We're going to do the same thing, by the way, when we go through and do the particular solution here, okay? But let's just take a look at the annihilator. The annihilator for 3e to the negative 3x is d plus 3. So d plus 3, if we take that and we take it by 3e to the negative 3x, okay? That's going to equal, okay? That's going to equal negative 9e to the negative 3x, okay? Plus 9e to the negative 3x, which equals 0. So that's clearly the annihilator, all right? Well, that's cool, because basically what that means is that d plus 3 times d minus 1 times d plus 3 y will equal d plus 3, right? 3 d plus 3 squared times d minus 1 y equals 0, right? So we end up with something homogeneous. Yes? And similar to our complementary part, we're going to end up with basically for this particular differential equation, we'll end up with y equals c1e to the x plus c2e to the negative 3x. And then I'm going to just write this as a naught, right? X e to the negative 3x. All right? Cool, right? And why did I have to have the x? Because if I didn't have the x, what I'd end up getting is linearly dependent solutions. Then e to the negative 3x's would be the dependent. So this is now going to be my trial solution. Basically, what we're going to do here is we're going to make a comparison. We're going to compare our complementary solution and the particular solutions or the general solutions inside of our complementary part to the non-homogeneous part, the e to the negative 3x. If they happen to match, we're going to need to multiply by powers of x in order for us to finally get a linearly independent trial solution. Okay? In this case, just needed 1. Just needed the x right there to be our trial solution. So now we're going to actually just plug that in. We've got, and by the way, remember to plug it into the original. Okay, so that's d minus, or d d plus 2d, d squared plus 2d plus, or minus 3. Let's just erase that because it's terrible. So we've got d squared plus 2d minus 3 times our particular solution, a naught x e to the negative 3x. First find yp prime, and that will equal negative 3 a naught x e to the negative 3x plus a naught e to the negative 3x. Yp double prime will then equal 9 a naught x e to the negative 3x e to the negative 3x minus 3 a naught e to the negative 3x. Cleaning that up a little bit, we end up with 9 a naught x e to the negative 3x minus 6 a naught e to the negative 3x. Okay. So now d squared, so that's going to be 9 a naught minus 6 a naught e to the negative 3x plus 2 times negative 3 a naught x e to the negative 3x plus a naught e to the negative 3x minus 3 a naught x e to the negative 3x. All right. And that will all equal what our original solution was, 3e to the negative 3x. So now what we have is this is 9 a naught x e to the negative 3x minus 6 a naught x e to the negative 3x minus 3 a naught e to x e to the 3x. Yay! Thank goodness. It's got to be zeroed. It's got to zero out. Okay? So we're going to have 0 a naught x e to the negative 3x. I just put that there because really important. If we didn't zero out, we'd have a problem. Right? And then minus 6 a naught e to the negative 3x plus 2 a naught e to the negative 3x. So that's negative 4 a naught. And then, yep, negative 4 a naught. So negative 4 a naught e to the negative 3x will equal 3 e to the negative 3x. So negative 4 a naught equals 3, and a naught equals negative 3 over 4. So my particular solution then here is yp will equal negative 3/4 x e to the negative 3x. And we have effectively modified our trial solution. So remembering that yc was equal to c1e to the x plus c2 e to the negative 3x, our whole y is going to equal c1 e to the x plus c2 e to the negative 3x minus 3/4 x e to the negative 3x. And that is our complete solution. So the big thing to capture away from here, the thing that's gone differently now, is we went in and we compared our non-homogeneous part to our complementary solution, saw that they actually shared a term, right, or shared a solution. And so consequently, what we needed to do is we needed to modify our trial solution by basically just multiplying by an x, right, or multiply by a power of x, depending upon the solution. And so consequently, we did that, and then what happened, right? Then we just went in and did our process again, right? We went in, we operated on a naught x e to the negative 3x, okay? By the way, we should set that equal to 3e to the negative 3x, okay? And then solve for a naught. And that gave me my homogeneous, the solution to my homogeneous differential equation. And that completes this.